I hope you can see my desktop.
Yeah, we can see.
Okay, so uh, this is my LinkedIn profile. If you're really interested, then you can check my profile there. And my experience includes some of local companies as well as some global US companies. And today I really want to talk about something that I learned in the hard way by making a lot of mistakes, and which this experience could be beneficial for some of the software engineering managers, software developers, and even for the business owners. So the talk is about microservices, LMS microservices in production, and what really LMS is and why we really decided to develop it at first place. LMS stands for Learning Management System, and it helps us to automate the business processes and increase the quality of the services, education services that we provide internally in Grace Academy. And today I'm not going to talk about the business side of it, but I'm going to talk about the technical side. So if you see, I have highlighted some of the technologies we use in there. We develop this application mainly in Java. We use microservice architecture. We use stateless microservices for scalability. We use GWT and OAuth. And we use CI/CD. The application is running in Google Kubernetes Engine, in Google Cloud Platform. And we have 80% to 70 to 80% unit test coverage, and we use some advanced concepts like service mesh, etc. So you may ask the question, why are you really highlighting all this stuff? Because many companies already doing it. But the interesting point is we did all this stuff not with some experienced developers who has 5 to 10 years of development experience. We just did it with some students who has less than a year of experience, and most of them even didn't know what a microservice is or what Java is at all. So in that process, we found some efficient methods which we can use to produce high quality and maintainable software. So before jumping into the results, I want to highlight some of the problems that in the software development process in the first place. So if we are developing software, some of the problems is that usually the business people who are responsible for making decisions, they don't understand the developers, but they make the decisions. And that at the end contributes to the failure of the application, and also it can cause the failure of the business itself. And most of the time, the developers find difficulty to convince the business people how to do things right and what is the right approach. Another difficulty that an average, a usual software developer uh, encounters is that our education system usually teaches more stuff how to do things wrong than how to do right. And when it comes to countries like Azerbaijan, which are small, we have our own set of problems that we will never be able to find enough developers which are very experienced, because even the biggest companies of Azerbaijan are not able to compete with US or European companies. So the experienced developers probably will leave the country, and you have to find a way to develop maintainable software with little or no experienced developers. So all of these factors contribute to the results of the software, and we end up with software that is not maintainable and no one needs it. So let's see what our educational system teaches us. So if we put ourselves in the shoe of
So
some.
sorry, Imran. I think there is some noise coming and going. Is it from microphone or something?
Okay. How is it now? Is it okay now?
Yeah, I think it's better now. Yeah.
So if
Yeah.
Okay. So if we
Okay.
put ourselves in the shoe of some Java developer who starts to learn Java, what we learn is some stuff like static methods, static fields, initialization blocks, constructor chaining, checked exceptions, inheritance, and etc. And then when we move on to design patterns, we will learn singletons, and then we will learn utility classes, factory methods, abstract factory, and so on and so forth. And we will learn all sorts of legacy frameworks like GSP, Servlet, GSPL, and etc. All this stuff uh, those are the things that we should probably avoid in production code, but a developer who doesn't have a lot of experience doesn't really know that these things are bad, but because the education system doesn't always highlight that, well, static fields, you shouldn't use them, or static blocks, you shouldn't use them. They just explain how this stuff works, and usually those stuff are advertised as good things. So that at the end, we keep repeating the mistakes over and over, and that means we produce more and more bugs. So what we can really do to avoid doing these mistakes? So the motivation was we really had this crazy idea. Can we create a software development company which we will hire people who has less than a year of experience, and we will train them, and we will not obviously be able to pay a lot, because once these guys get experience, they will leave the company. We accept this fact. And can we establish a DevOps pipeline which doesn't only produce software, high quality software, but also it contributes to the habits of the developers. And in other words, it produces developers with high quality coding habits. So we did it, and I think it was quite successful. So as a result, I want to share this experience, what really helps the developers to learn stuff quickly, and what really helps us to reduce the bugs that we produce and put in production. So the architecture really matters. If we go to a little bit history, in 2010, I was developing an application, and it was using monolith architecture. Initially, things were pretty good. We had very good progress. But as you know, that the successful projects, they start to grow. And as they grow, the problems start there. So as our application started to grow, we decided to add more people. That is where things started to break up. So whenever we added a new person to the team, they started to do crazy things which produced more bugs, and we ended up with fixing more bugs than actually delivering stuff. So in this term, the architecture is really important. If you choose the wrong architecture, you will end up a code base that is so huge that no one understands. So microservice architecture is a good one because at least the individual modules are small enough that one developer can understand, and it doesn't take for them 6 or 7 months or one year to understand what actually this module does. It's just a matter of a week or less, because the application module itself is very small, and they don't need to understand all the modules. They need to understand only a single module that they will do the development. And this architecture is very good because in terms of scalability, I don't mean the application scalability, I mean the scalability of the development team itself. It works well because the teams can be isolated from each other, and the development process can be done parallel. So after architecture, another thing that really matters is the infrastructure. So if you don't have a DevOps pipeline, you will end up a lot of maintenance work which requires people. And if you are a small software company, probably we will not be able to afford to pay for these people. But fortunately, if you have the right architecture and the right infrastructure, we can automate all these things that will eliminate the need for hiring more people. And this actually works very well because once your infrastructure is flexible, you are able to automate all these things and you can quickly release your deploy your changes to the production, and this brings the agility. So I would say agility is equal to your architecture plus your infrastructure. The two cannot be separated from one another. So if you decide to do microservices with usual tools like virtual machines or machines that are installed directly on hardware, probably this will not be work very well. But the devil is always in the detail. So if you develop the microservices with bugs, that doesn't necessarily mean everything will work properly. There is always the problems with the details, which most of the developers keep doing it over and over, and it takes years to learn how to avoid them. So we decided why not to create a pipeline where we can put all this stuff together and create a checklist where we put all the bad things and give this checklist to the developers in advance so that if you are going to create a new feature, those are some of the stuff you should avoid. And this was quite efficient. And there is also the other stuff that we can apply in our development pipeline that can reduce a lot of bugs and a lot of issues in advance. For instance, some of these check code quality analysis tools are very efficient to producing high quality code because uh, the developer is limited to the amount of stuff he can do. For instance, let's say in Java we have naming convention. It's not if you violate the naming convention, that doesn't mean that your code will not compile. It will compile, but you are violating the convention. That means it's bad code, which is hard to understand. So applying these tools can help us to detect such issues and enforce all these best practices. Also, for instance, find bugs and find security bugs. Those tools can detect a lot of bugs which the developer produces, and also they can detect some bugs such as SQL injection and XSS attacks, that code that is vulnerable to XSS attacks, and we can avoid all this stuff in advance. So these tools help the developers to learn the stuff that they shouldn't apply in production code, and that in return contributes to unified and maintainable clean code that everyone understands. So another very important aspect which I found the most efficient is enforcing test-driven development. So when we enforce test-driven development and when we limit the number of frameworks that the developers can use for testing the application, they cannot test the code because if the code is not testable. So they need to go back and refactor the application in a way that is testable, and testable code always means it is better, and it uses the industry best practices such as loose coupling and a single responsibility principle. So we enforce 100% test coverage, and this really helps to guard us against integration hell in production. So what we really do is in this development pipeline, we set the coverage targets and the developers strive to reach them, which helps them to apply the best practices and produce code that is testable. Another thing is, there is another thing when we talk about test coverage, we need to highlight the difference between code coverage and test coverage. So you can write code like this, which in first look, it doesn't look like there is an issue, but actually we can write a test like this, which will cover all the tests, and at the end we have 100% test coverage. And you would say, well, everything is satisfied. We have nice code, we have 100 test coverage, and we can, well, put this code in production, but it is wrong. So line coverage means that at any point, if we execute this test, how many lines of code is covered. In this case, it covers 100%, but this doesn't mean we have 100% test coverage, because let's say that some developer doesn't understand what this code does and sends a null as a value, or sends something that is neither corporate or individual customer, then we return a null, and probably this will break something in the application. And to find out such bugs, we uh, we waste a lot of people's time. We waste the time of the DevOps guys. We waste the time of the developers. And this stuff, all this stuff can be avoided by applying TDD and test-driven development. So if we write the test like this, now we see that we have missed so many details in the code, which we wouldn't have if we did test-driven development in advance. So this stuff cannot be detected by any automation tools. So we enforce code reviews. And in code reviews, we distribute a list which the students can see what they should pay attention when developing the code. And this really helps them to learn how to do things right, then how to do them, how just to do them so that they deliver their functionality. So in this way, we also encourage the people to do code reviews, review of peer reviews, so that they can learn from each other's mistakes. And this turns out that it is really helpful. So the next steps is that we plan to share all these findings regarding to this pipeline with the community, and we will make it open source so that we can learn from community feedback, which is very important to us. And also we think, in my opinion, creating a true microservice architecture requires a lot of collaboration. You cannot do it alone. So it is important to do the stuff open source, and it also can be used as a framework for many startups and companies, small companies, which they can base their development process based on. So that is all about the process, and I can show the not to do list. So this is the checklist which we provided students during the development process. And when they add something wrong, we just put a no here and reject the ticket. And then that encourages them to learn what exactly they are violating, and they don't do the mistakes in production. And this process is enforced in this CI/CD pipeline. And at the end, we really found out that it is possible to develop high quality and maintainable code with people who has just 5 to 6 months of experience with Java at all. So if I show you the code, you can see it is understandable. There are no violation to the naming convention and etc. And it does the things properly, and it has enough test coverage. And the interesting part is all this stuff was done with people with less than a year of experience. So this process, in my opinion, was quite efficient for doing this software. So that is all about it for today. Any questions regarding to this process and etc.?
Thank you so much, Ruslan. I guess we can go for questions. I think DevOps, most of the guys I know in the chat also in DevOps. Let's Tarlan also joining, I guess. He's from, works in Pashawan DevOps, so yeah, let's let him join too. Do you want to open the question? Let's see if.
Yeah, okay.
Okay, let's see. Session08. Is it open source? I think, can you see in the meeting minutes? You want to share or you want me to share?
Yeah, I see. Okay, let me share. It's not, but we plan to make it open source because we are also interested to get community feedback and involve as many people as possible. Can we see a demonstration? How big is the development team? Do you use any kind of code review tool such as? Well, yes, the development team, we don't have a team at all. We have the students. Usually we have this training programs which last for 6 months. After 2 or 1.5 months, they start to contribute, and we provide this checklist. And usually in each training session, we have around 10 people. So right now we have 2 training sessions. We have about 20 people. And how big is the development team? We can say it is about 20 people, but it can be scaled to any size because of the architecture as well as the stuff that we enforce during the development process. And do you use any kind of code review tools? We don't use Gerrit, but we use KMD, check style, and all the other stuff that I have mentioned above, like find bugs. So all these tools. And these tools, the beauty of these tools are that if you violate anything in your code, this tool doesn't let the code to be compiled. So the pipeline fails and the developer needs to go back and fix the code accordingly. And this results in a code that it doesn't have developer specific stuff. You cannot distinguish whether this piece of the code was developed by this developer or the other one, because these tools enforces the code styles, and this results in unified code. So what is the next question? How did you implement test cases, independent microservices? So I really don't understand the question. So we have in general, we have unit tests, we have integration tests, we have end-to-end tests. In here, what I showed you is mainly unit tests and integration tests for individual APIs.
So I think that's clear that what Ruslan mentioned, like as a unit test, it's belong to each microservice. I think here they're asking the integration between the microservice.
Okay, so for integration between the microservices.
Yeah, because if you have like hundreds,
what I showed here is not integration between microservices. They are just testing if individual microservice is working fine. But also it is possible that you change something in this microservice. You remove, let's say, one API which is used by a different microservice here. And for detecting this, we use contract tests. What about data consistency for each microservice? What do you mean by data consistency? Could you please add some more details?
Does it mean the state?
Maybe it is referring to transactions, right?
I think what you mean, you can also turn microphone and elaborate in case, but do you mean like if you have two microservices and if,
Yeah, for data consistency, we use Saga, which is
yeah.
not immediate consistency, which becomes consistent over time. So we have this stuff which undoable operations. If some operation fails in one microservice, we redo all this, we undo all this stuff which is done in dependent microservices. So we use Saga.
So on top of what Imran said, just to make clear, the database is not like done as a microservice. It's all the stateful data is stored in database, and so only the microservice is for the stateless part. It's divided, I guess.
Yeah, for database, well, we use single database. That doesn't necessarily mean we share the schemas. We have multiple schemas. That is equivalent of using multiple databases. So, as you said, you are using Java and which GVM you are using in container regulator GDK, or we are using. Let me go to this. Kubernetes files. Here we have what we are using.
Elvin, I am moving your question also to meeting minutes from the chat, just to let you know. Yeah.
Okay. It's in Docker file, actually. We use OpenJDK, as far as I remember. Yes, OpenJDK. This is the base image, which contains the base OpenJDK. Any other questions?
Yeah, there is one from Elvin Effendi.
Which takes nearly 250 megabytes of memory. Yes, so maybe. Yeah, it takes. How much microservices do you have? How many? Okay. What are your criteria when deciding whether a new service should be standalone microservice or built into another service? Well, it depends. So we right now have, how many we have is 1, 2, 3, 4, 5. This is not a microservice, 6, 7, and eight microservices at the moment. So it depends on what operations it is doing. It depends on the business side. So let's say course MS, this is related to managing the courses. And then we have payment MS. This stuff is solely dependent on payment. So it is probably makes sense to separate these things rather than put everything in together. So this is how we make the decisions. So what are the issues you run into is growing number of services? Yeah, we have a lot of issues we encountered. That is why I am planning to make this stuff open source, because I also want community feedback, because some stuff that we did, we may assume that we did properly, but maybe we didn't. Maybe there is a better way to do it. So we will make it open source to get this feedback. One thing right now I really see that is becoming a problem is that we have code which is the same related to configurations. So let's say this configuration code and etc. And this code is duplicate across all these microservices. So we didn't assume this would be a problem initially, but now I see that they share a lot of duplicate code, which we need to refactor and extract and put into a different module and share instead, because later on, if we need to change something in any of these microservices, this will become a problem because we will make this change in multiple places. So any other questions? Did I answer all of them?
I think so. The questions, any other questions, guys, girls? And just by the way, Ruslan and Imran, they're doing regularly online webinars. Really appreciate their efforts. Unfortunately, it's only Nazari, so only people who can understand can watch. But hopefully, over time, we can see also some the English webinars from them. It's great, really product. And once Imran showed me, I really was curious that, hey man, that should be really open source. That how you can. That was always also a challenge for me because one of the projects I was building in the school. And
there's one question: why are you using JDK8?
okay.
Well, JDK8 is one of the mostly used version of Java. And the main thing I'm interested in JDK8 is Lambda functions, which it provides. And that is why we decided to use JDK8, because we wanted to do stuff on something which is very stable.
Yep. Thank you so much. And if you have any questions, both are guys also in Go Slack group, and you can just jump over the LinkedIn. And for open source, hopefully once you guys make it open source, please also put in the Slack that the guys can join and contribute.
Oh, okay. So I think we have more questions, but we can probably discuss the details in Slack.
Oh, we have more questions? Yeah, let's go. I
Yes,
think we
there
have
is.
time.
What we have, I would have liked the contrast this into classic monolith with model design, but
Oh yeah.
sure. Yeah, okay. So this is one thing I want to highlight. So it looks like a monolith, but it is not. Why? Because a monolith actually has its own benefits. So if you have a monolith, you have a single item that you can put in one Git repository and maintain. But if you have microservices, let's say I put every single microservice in different repo, and if you want to change something, you need to switch between the ID in this project and that project and so on. So we use this modular approach. We put everything in one project and then we have modules, but that doesn't necessarily mean this is monolith, because every single module is completely independent from other, and each module is deployed into its own Kubernetes container or pod, and they really don't need the other module to be able to run. So unless you send a request which requires another microservice, they don't have any dependence in between. But this is a very good way to manage multiple microservices. Even we have in other projects, we have other technologies like Python. Even this Python project is included in the same project as a module. So I hope this answers your question.
I like the monorepo approach, but what I was implying mostly is related to avoiding the network call for the interaction between the services. So like you said that, for example, the payment processing and courses services, they are two different services and they interact with each other through HTTP requests or gRPC. I don't exactly know what it is, but it is a network call, right?
Yeah.
But alternatively, you could put them into a same container, like same app, and then just have the isolation of responsibilities using classic OOP design. Like this is classic monolith versus microservices discussion, right? I don't know if you have time to discuss this.
Mm-hmm. The thing is, when it comes to what we really wanted from this project, speed wasn't the main problem. So for any request, the response time is less than a second. So it's fairly good, and we didn't even bother with trying to reduce the connection or using gRPC or other technologies. But yeah, it's a good point. It's good comment. So that is why we want to make it open source, so that we can learn from other people's opinion.
Thank you. I love the checklist approach. I'm going to repeat that.
CDC, I'm interested how you perform CDC. Could you please, I did not get what they mean by CDC. Integration tests. So we have, for here I can show you the integration test we are doing with mock MVC. This tests only a single REST API, but also we have smoke tests and end-to-end tests which are executed after we deploy the application into Kubernetes. So we also have contract tests, so that if we break anything in any microservice which should be consumed by one client, we can see this in advance. So any other questions? For integration tests, we use this. It can be called also a unit test for a single controller, but also we have smoke tests which are executed after the application is deployed into Kubernetes cluster. So in every feature story, when we want to migrate it into master branch, we deploy it into Kubernetes and we execute the smoke test and we make sure it is still working fine. Any other question? Yeah, that means contract test. So we use this one. So this framework is very helpful in terms of making sure that you didn't break the contract between your API and the consumer. I hope that answers your question. Any other questions? So if we don't have time, we can move
on. Any last questions? And please, add meeting minutes if you can. If not, then chat is also fine.
Well, I didn't expect so much interest in this topic, so it is.
Yeah, that's really.
Yeah, it's probably, it actually encouraged me to make this stuff open source as soon as possible, so that we can get the community feedback. It doesn't necessarily mean we do everything in the best possible way. Things evolve over time when you get more people's feedback. So yeah, we will try to make it open source.
Yeah. Definitely, Imran, because that's, as I said, one of the project, my side project I was working, I was also in school, and it was always a challenge for me how to bring the, as you said, junior level or people don't know much and within short time to bring them speed and to make them contribute.
Yeah, that
like
was
you figured out.
The main thing which I was worried about most. And the whole idea of this project, well, we could find some open source library for doing this LMS thing for our business requirements, but we decided to develop something which is a fairly good sized application where we can test, is it possible to bring people with little experience and develop high quality software, and the results were pretty impressive. So I decided to share the experience.
Perfect. Thank you so much. Thank you so much, Imran. Thank you so much for Index Academy, Ruslan, all the guys putting effort, and we really appreciate your efforts for the online webinars. And please keep doing it. We really
okay. Thank you so much.
It's really helpful.
I hope it was helpful.
Yeah, it really helps for community, all these kind of efforts. Appreciate. Okay, let's